All right. First definition today is the vertical angle theorem. And this is the one that lets us say that vertical angles are equal. The definition says they exist. The theorem says they are equal. The parts to whole theorem is a very handy theorem for segments or angles. It says the measure of the whole figure, and that would be an angle or a segment, is equal to the sum of its parts. So if we were to draw a picture like this, what I could say is that angle 1 plus angle 2 is equal to angle PQR. And this works also the same for segments. If I have a segment like this, I can write that AB plus BC is equal to AC. Linear pair theorem lets us say that if angles form a linear pair, then they are equal. The congruent supplements theorem and congruent complements theorem sound complicated, but they're really not when I draw a picture. Now, the congruent supplement theorem says if two angles are supplements to the same angle, then they are equal. And the congruent complements theorem says exactly the same thing. If two angles are complementary to the same angle, then they are equal. This is probably best shown by an example. I will show you one example and it will kind of stand for both of them. If I have angle 3 and I have angle 2, and let's draw angle 1. And I said angle 3 plus angle 2 equals 180. That would make them supplementary. And angle 1 plus angle 2 equals 180. It should feel pretty good in your gut that angle 1 has to be exactly the same as angle 3. It's nice if you think about some actual numbers. If this were 50 and this were 130, then this would have to be 50 if 1 and 2 were also going to be supplementary. It works the same thing for complementary. Cross off segment addition postulate and angle addition postulate. That's just another way to say parts to whole, and we're going to use parts to whole. Bisector does exactly like it says. It is a line, a segment, or a ray which cuts an angle or segment equally in half. This is a very useful theorem. Distance formula, this is review between ordered pair XY, two ordered pair. The subscripts just mean two different ordered pair. The distance between those two is you take your x's and you subtract them, and you add to it my y's, subtracted and squared, and that gives you your distance. Midpoint, you take a set of ordered pairs, and again, the subscript numbers are just saying I have two different x and y's. Midpoint, you want to find the middle, which is like an average. add them, divide by 2, add the y's, divide by 2. You're finding the average. Remember that your answer is an ordered pair. Lots of kids try to add them then when they get all done, but you're finding the average x value and the average y value. Now we are going to just get to some examples. If I give you a statement, what is the conclusion you can make from it? This is how you would work a proof. If I know that CD is perpendicular to AB, my conclusion is that angle CDA equals 90, or that angle CDB equals 90, and both of these are by definition of perpendicular. So if I give you some information, what is the first line of your proof? What does it let you say next? Now there's a trick with number 2. BD bisects angle ABC, and you have to think about this ray going in that direction to cut this angle, and only that angle exactly in half. So what I conclude is that angle ABD is equal to angle CBD by definition of bisector. Given two intersecting lines, the conclusion you can always draw is that you have vertical angles. So angle 1 equals angle 2, or angle 3 equals angle 4, whichever pair you need, by the vertical angle theorem. If I'm given 1 and 2 are complementary, the thing I can say is that angle 1 plus angle 2 is 90. And that's true by the definition of complementary. Same way if I said they were supplementary, you would write the equation and say they were supplementary by definition of supplementary. Given that BD bisects AC, now this is a lot like number 2, but look at the directions. It bisects the segment. So the bisector goes in this direction. Now we know nothing about the angle, and we only know about the segment. And we know that AD is equal to CD by the definition of bisector. Now, if we're given that E is the midpoint of AB right here, that tells me that AE and EB have to be the same. And that is by the definition of midpoint. Yes, that looks a lot like bisector, but remember what we were given, a logical chain. From midpoint, we get equal segments by definition of midpoint. Given the diagonal AC bisects diagonal BD, what can you conclude? Again, be very careful about the direction of your bisector. AC bisecting the diagonal. So this diagonal gets cut in half. We know nothing about the other diagonal. So I know that DE is equal to EB by definition of bisector. Now we're going to start working on a proof. And the biggest thing is to mark your picture. Put down what you know, what does it give me, what kind of number sentence can I make from that. So here we go. They give me bisector, I'm going to come back to that one, and they give me equal angles. Tell me angle ABD is equal to angle CBE, and that BF bisects angle ABC, and that is given. Now the first thing I'm going to go for is that bisector information. Here is the bisector of the big angle. So that means I get the two halves of the angle. So I know that angle ABF is equal to angle FBC by definition of bisector. Now I want to figure out how to get my prove pieces into my proof. That parts to whole theorem is a great way to do that because now I know these are equal. I can see that they are part of the two angles I just wrote about. So I'm going to write that angle ABF is equal to angle ABD plus angle DBF. And I'm going to say that angle FBC is equal to angle FBE plus angle EBC. And what I'm doing there is parts to whole. I just took the smaller angles and made them equal to the bigger one. Now we're going to start doing some substitutions. What I know is that these two guys are equal, and now I know that these two guys each have their own statement. So what I can conclude is since they're equal, those sums are also equal. So that's my next step. Step 4, angle ABD plus angle DBF is equal to angle FBE plus angle EBC. That is by substitution. Now I'm going to do another substitution. This piece of information says that those two angles are equal. That same information shows up right there. So I'm going to replace down to my next spot. And so instead of ABD, I'm going to write that angle CBE plus angle DBF is equal to angle FBE plus angle EBC. That is also by substitution. What did that get me? That got me this exact same measure on both sides. If I subtract that value from both sides, I am done. This was what they wanted me to prove, and I proved it by subtraction. Now, the last proof is very simple based on the previous one. I'm given those two are equal. AB equals DC. That is given. I'm going to use that parts to whole theorem again. And I'm going to say that AB plus BC equals AC. And I'm going to say that BC plus CD equals BD by parts to whole. Per the given, these two guys right here are equal. These two guys right here are equal. So these sums equal each other. AB plus BC equals BC plus CD by substitution. I have that same value of BC, whatever it is on both sides, so I can subtract it. And I have that AB equals CD, and that happens by subtraction.